All right, question 2-96. The graph of sinusoidal functions, sine and cosine, have top maximum points and bottom minimum points in the middle. What are we trying to do here? For each function below, decide where it starts and if it increases or decreases from that point. So let's go back to our Desmos, and we just want to look at the sine of x. So what it's trying to get at is we're reflecting, just like we reflect any function by putting a negative in front of it. We want to reflect the sine and the cosine function. So let's go back to having this just be the regular cosine and to having our red be the regular sine. So what I need for you guys to take away from this is that sine starts at 0 and then goes to its maximum point, and then goes all the way to its minimum point, and then one full cycle brings you back to 0. Cosine, on the other hand, starts at its maximum point. It starts at 1, then it goes all the way down to its minimum point, and then it goes all the way up again to its maximum point, and that is a whole cycle, just one cycle right there. Actually, I wonder if I can make this a little more visible. If we said x is equal to 2 times pi. Okay, so there's one complete circle. It starts at 0. Okay, let me see if I can do that. X equals 0. Okay, starts at the green line, one whole circle, starts at the green line and ends at the blue line. And oh, I wonder if I can just make these the same color, if I can make these both blue. I think, nope. Well, I think you can. I think I just don't know how to do that right now, but we'll work on that. So the whole circle starts at the green line, goes to the blue line. Halfway through the circle would be a pi, right? Pi is half of a circle, but a whole pi. So if we say x is equal to pi, okay, that's going to be halfway through. So that's cool. So that's one entire period from 0 to 2 pi. The blue line's 2 pi. What were we doing with that? I got so excited. Oh, we wanted to see what would happen if we reflect these. So let's start with, let's take our cosine off. We just want to look at the sine. Okay, so it goes up and down. That's half a circle. Then it goes down and up, and that's the other half of the circle. What happens if we take that regular sine of x and we put a negative in front of it? Okay, so our amplitude is going to be 1, but we are going to make it -1. Okay, do you see what happened? Each point, our zeros didn't change, right? But each point, like here, pi over 2 is 1, got reflected, so it's pi over 2, but it is -1. Okay, so if you are trying to model something and you want to use the sine wave, but instead of going up and then coming down, it goes down and then comes up. If that's what you want to happen, you just use the sine wave and you just flip it over by putting a negative in front of it. So let's just do the same with our cosine. We'll just start with our basic cosine. That was our black one here. Whoops, that was cosine plus 1. Here's just our cosine. Okay, and what I'll do for this one here below it, I will put it was red or burnt orange or something. I'm just going to make it negative. There. So if you want to model something that starts at the top, like a regular cosine function, you want to use a regular cosine function. Starts at the top, but then it starts to go down. But what if you want to model something that starts at the very bottom of this curve and then starts to go up? So off the top of my head, I'm thinking maybe we want to model a Ferris wheel where you get in at the bottom and then it starts to go up, right? So we're going to put the negative on the outside of the cosine, but a Ferris wheel, it doesn't start at -1. It would just start at like 0 or something or a little bit above. But if we just make it 0, if we shift that negative cosine up 1, okay, now what we have is a Ferris wheel. So you can get on at the bottom at 0, 0. You start going up, you reach the top, then you start coming back down. And that is once around the Ferris wheel. So cool. We can use this to model different types of situations, which is going to be kind of your mini project, which is the Form B part of your test. So this will definitely come in handy when we're doing that. And I think I had one more. That was basically question 96. One more question was just 98. Work with your team to write equations for each of the following functions. write one equation using the sine and one equation using the cosine. Okay, so let's take a look. These are all the same thing, they're just shifted, right? So in this top one, it looks like our, let's see, it looks like it starts going up a little bit first, and down, and it goes all the way up to 2, and it goes all the way down to -2. So we're going to have something where our amplitude is 2. It's from 2 to the midpoint here is going to be 2. So our amplitude is going to be 2. Cosine and sine are going to be the same thing. It's just a matter of what we want to do here. So let's see if we can find a point. This is pi. This is 2 pi. Which one, sine or cosine, is 0 right here? Okay, let's just start playing around. Let's say we want to use the sine wave, which starts here at 0. Oh yeah, this is what we want to do. Sine wave normally starts here at 0 and then starts going up, right? So it looks like we took the sine wave and we just backtracked it by pi over 6. Okay, so I bet that that's what it is. So if we put those both into our Desmos here, if we just put in the original, let's leave all these parts in there. If we just put in the original sine wave, which was here, and we have to give it an amplitude of 2, right? Because it looked like it went, instead of going just up to 1, it went all the way up to 2. And then we just want to shift, we want to shift this point that was 0, 0, and we want to shift it 1 tick mark back, right? And it was 1 tick mark here would be pi over 6, this would be 2 pi over 6, this would be negative pi. So we want to shift it backwards, pi over 6, or to the left, which means we put plus, actually. And then on Desmos, you just put in pi pi divided by 6. Okay, and we just shift it back to pi over 6. And then over here it is 5 pi over 6. So we just shifted it. We changed the amplitude and we shifted it backwards by pi over 6. We shifted it to the left, I'm sorry, I shouldn't say backwards, by pi over 6. So let's see what the second one, let's go ahead. Where is our 0? So we've taken something and we've shifted it. We've taken one of our sine or cosine waves and we've taken and we shifted it from the midpoint being at 0, okay, to the midpoint being at 3, right? So we've shifted something up 3. And then I bet if we took our cosine, okay, and it's pi over 6, and our cosine starts at the top, so if we make it negative, it would start at the bottom. So let's look at our cosine wave this time. So if we take our cosine wave and we change it by turning it upside down and then shifting it left, I think by the same, I'll go double check this, but let's try this, plus pi divided by 6. Oh, and then up on the end, we moved it up by 3. Okay, so let's see, what does that look like? Okay, so 0 approximately 2 point something. 0 approximately 2 point something. Yep, looks good. And pi is approximately, at pi, it's approximately 3 point something. At pi, which is here, is going to be approximately, yep, 3 point something. Looks good. looks like we did it. So again, I know this was just like showing you what was happening in that problem. You're definitely going to want to sit down either with me or on your own and try some of this. And tomorrow I will give you guys the little mini project, so we'll have time to get started on that. All right, get some sleep.